All right, what I'd like to show you guys is how to go ahead and graph a quadratic piecewise function. My function is h of x, where I have 3 minus x squared when x is less than or equal to 0. And my other part is x squared plus 2 with my constraint of x is greater than 0. The main important thing I want you guys to remember of a piecewise function is it's a function when we have constraints. So if you guys look at this first function, 3 minus x squared, you guys would notice that this is going to produce a parabola. And it is going to be a parabola that's going to open downward. And my y-intercept is going to be at 3. That's some things I know about from going from my parent function of a parabola. However, a couple things I want to notice is this function is only going to be true when x is less than or equal to 0. So what I did was, I kind of know what the general shape of my parabola is going to be. But what I created was a table over here that we can go and fill in the values, and then that will give me a general outline of what exactly, or at least 3 points that my 3 points that my parabola will follow. So first of all, I'll say, all right, when x equals 0, what is it going to be? So if I put in a 0 in for x, I get 3. And notice this is x is less than or equal to 0. So I go up to 3, 1, 2, 3, and I'm going to do a filled in circle because I know that this is less than or equal to, so therefore this value is part of the function. Then I plug in negative 1. Negative 1 squared is going to become 1. 3 minus 1 is 2. So I go to negative 1 up 2. And then I'm going to do negative 2. Negative 2 times negative 2 is 4. 3 minus 4 is negative 1. So at negative 2, negative 1. So roughly, my graph is going to continue down in this direction. All right. Now I need to look at my next function part of on my piecewise. This says x squared plus 2 when x is greater than or equal to 0. Sorry, let me fill that in. So now what I did was I created a separate table to help me graph these points. So on this one I have when x equals 0, I have 2. However, notice that when x is 0, we know that 0 is for this function. So therefore, this is going to be a open dot. It's very important for you guys to understand at one point we can only have one of these functions be true for there, or it wouldn't be a function, right? Because if that was a closed dot, then therefore it wouldn't pass the vertical line test. Does that make sense? So this has to be, make sure we have an open dot for it to be a function. So at 0 we have 2. Then I plug in 1. 1 squared plus 2 becomes 3. So go over 1. Up 3, and then we plug in 2. 2 squared is 4, plus 2 becomes 6. So I go over 2, up 6, 1, 2, 3, 4, 5, 6, and I notice my graph is going to follow this path. So therefore, this is how you graph a piecewise function. What you need to make sure that you do is for each function, you create a table of at least 3 points to give you your graph. And you just follow kind of forms, and then make sure you follow your constraints, and you either use the closed or open circle to represent the constraints. Yes?
It doesn't say that it's a piecewise function. It says graph the function.
Graph the function, but since it's a piecewise because you're given 2 different functions. I mean, here's your function. This is your function.
But what I'm saying is, like, what would you do? So you wouldn't do like, if like let's say it's a 1, you just like wouldn't switch the. Like, okay, let's say because you have a negative 1. Well, obviously the negative 1's going to go up there for the top, it's going to be plugged up for the top equation. Well, let's say you have a 1, it's going to go for the bottom equation, or whatever, but you don't connect them, like they're 2 separate problems. You won't connect the lines together.
Yes. Here's an important thing for you guys to understand. This is your function. This is your function. However, this function is only true when x is less than or equal to 0, and this function is only true for when x is greater than 0. So that's why if I pick the number 4, which function am I going to use? I'm going to use this function. Okay, so you can't use both functions. So this is a general function. That's why they say just graph the function. But it is a piecewise function because we have 2 different within our function. We have 2 different functions that we're graphing with their given constraints. All right. So that is how you graph a quadratic piecewise function right there.